the problem from yesterday. Let me just, okay, this is the problem from yesterday. And just some reminders of what we do with these problems. We get one side to be 0, and then we set it equal to 0. Yesterday we found the zeros. Today we'll find zeros or asymptotes. We find all the zeros. We make a number line. That was still finding the zeros, and put them kind of in numerical order from negative infinity, the first 0, the next 0, the next 0, however many there are, and then to infinity. We make our test intervals. When we pick our x's that are in that interval, then we test them, and the best place to test it is in that factored form, x plus 4, x minus 1, and x minus 6, and then just decide if the sign is positive or negative. Then we put those on that number line to kind of see where it's going to be positive or negative. And then based on if it's equal to 0 or greater than or equal to 0 or just greater than, in this case, that won't include those. Lay down the road, if it's an asymptote, it won't include it no matter what. The only thing I hadn't done on this one is just looked at the graph. I'm disappointed with the book authors because they're actually using a scale of 2, and they did not write that on there. So then our solution is this, and excuse me, when we look at this, this is -4, this is +1, and the graph is positive above there. It's not including those 2 points because it's strictly greater than. And then from 6 to infinity, it's also positive. So a good way to kind of just validate that I've done that correctly. So now our next one, I wanted to do that because now this is going to be a little bit of unusual circumstances. So here's our next problem, 3a. We'll go through that same process. X squared plus 2x plus 3 is less than 0. First step, get one side equal to 0. It already is. Second step, set it equal to 0 plus 2x plus 3. Factor, in this case, this is much easier than that last one where we had to do all that synthetic division. Factor, does it factor? Yeah, that's a problem. It does not factor. So if it doesn't factor, what do we do? Quadratic formula. So A is 1, B is 2, C is 3. X equals -b plus or minus the square root of, and I'm putting the numbers in, b squared, which is 4, minus 4 times A, which is 1, times C, which is 3, all over 2A, which is 2 times 1. Now, you know, I don't really teach this dynamic, but this is called the discriminant, correct? And it discriminates between, you know, what kinds of zeros we're going to have. And so when I look at that, when I'm even writing it, I'm like, oh, that's going to be 4 minus 12. Why is that an issue? It's negative. So this is going to be the square root of a negative. So there are no real zeros. So graphically, without even really looking at that, you know, I'm not going to look at my picture, but graphically to me then, it's a parabola that has a u upwards because it's a leading coefficient of positive and it's x squared. So it looks like this, and it's never crossing this x-axis, correct? Because, you know, it's just up there and it goes up there. So that means that when I do a problem like this, it's either everything works or nothing works. Does that make sense? So in this one, there's no real zeros, nothing to try. And so when is this less than 0? Never. Since, and you know, I'll show the good graph as well, so it's a little over that way more. Whoops. So this will, the graph never crosses the x-axis, and all values are positive. So our answer here is the empty set. There's never a place where that is going to be equal to, or excuse me, less than 0. It's never going to be less than 0. So B is actually not much work. I'll let you kind of write yourself a little note about that because we're doing our unique situations right now. Now, part B of this one is the same function, but greater than or equal to 0. So we've kind of done all the legwork for this one. 3b, x squared plus 2x plus 3 greater than or equal to 0. It's the exact same graph. I don't really have to deal with that. So when is this greater than or equal to 0? Always. And so from part A, and I'm writing a little more than sometimes just so that it's on my notes. From part A, all values of x give a positive answer. So our solution here is negative infinity to infinity. Because a minute ago, I looked at, and I'm thinking about the graph right now. A minute ago, I looked at there's no real zeros, right? No real zeros, so it doesn't cross. So the only thing it can be is it either has to be u up like that or u down like that. Since this is positive 1x squared, it's got to be that one. And so since it has to be like that and it's not touching this axis ever, it has to be above, so every value is positive there. So we kind of have to use our kind of tools from previous work. Other things that can happen here are maybe instead of crossing the axis, it touches the axis, right? And so that's kind of our next special case as we go through this. So here's another problem. 3c, this is a new rule, x squared plus 12x plus 36 is greater than 0. And we'll approach this one just like yesterday and so far today. So we want it to be just greater than 0. So first I'm going to set it equal to 0. And find the zeros or roots. If you're doing it this way, what multiplies to be 36 and adds to be 12? 6 and 6. So it's plus 6 and plus 6. So what's the 0 or root? Negative 6. X equals negative 6. They're the same, or I'll just use terminology that we need to remember. It's 6, or negative 6 multiplicity 2, right? Kind of as we look at that. So now I do have intervals I can look at for this one. And I only have one key value, which is my negative 6. I'm going to go from negative infinity, that's a bad sign, but I'm sure you know what it is, to positive infinity. So my interval table, and I didn't leave myself great room, my interval table, let me ask you what these intervals are. What do you think my first interval is, Bo, from where to where? Negative infinity to negative 6. And where's the next interval? Negative 6 to infinity, and that's the interval, and then x and the sign of y. So when you're ready, Kate, pick a value from negative infinity to negative 6. Negative 7. And then when we're looking at that, we're just putting it in here and seeing if it's greater than or equal to, or greater than or less than 0. When I put in negative 7, is that positive or negative? And a negative times a negative is a? Okay, so negative times negative equals positive. That's kind of how I personally do that. Amy, pick something for me that is between negative 6 and infinity. So positive 7. And so if I put positive 7 in, will this be positive or negative? Positive or negative? Positive. And what is a positive times a positive? A positive. So in both cases, that's a positive. So graphically, think about what this looks like. This is positive 1x squared, and so it's a parabola that looks like, has that U shape right there. It has a 0, oops, I'm picking up the whole thing. It has a 0 at -6, so it touches at -6 and then kind of goes up. So all of the values are positive or 0, right? Because at that -6, it's actually equal to 0. So that kind of helps us think about what's happening in this one. Just a note to point out, and I think we covered this earlier, that this multiplicity 2, remember me standing here and saying that a minute ago? Multiplicity 2, if the multiplicity is even, that always means, if this is my axis, that it just touches that axis, right? And if it's below, it would just touch that axis. So if it's an even multiplicity, it touches. If it's an odd multiplicity, it crosses that axis. And so then there's the picture of that. 1, 2, 3, 4, 5, 6. There's that value. So this one, now I want to look at, when is f of x just greater than 0? Well, I'll put my positive there and my positive there. But remember, this is when it's equal to 0. Oh, it looks like not equal. This one was when it is equal to 0. So can we include -6? No. So our solution for this one is from -infinity to -6, and parentheses because it's not included, union with -6 to infinity, because all the values are positive except right there. That's all positive. That's all positive, but at that value for -6, it's not. So suppose it had been strictly less than. What would the answer have been? No. If it was strictly less than, no solution, because it's never less than 0. How about if it had said greater than or equal to 0? Everything, yep, -infinity to +infinity. So these are kind of the trickier ones that don't give us exact values as we go. Now, that's a polynomial inequality, correct? Because that's a polynomial equation. Next is rational inequalities. The only difference is we still find zeros, but we also find the undefined terms, and we just go through this exact same process. Okay, but we have to be careful that undefined terms, it's never equal to those as we go through. Oops. And actually, this was the other one. I'll just show you. Oh, and I forgot to say that. If it's less than or equal to 0, do you agree that it would be -6, right? Because that is equal to 0. So it's never really less than, but less than or equal to would work. Okay, now we're going to look at rational inequalities. Okay, so for rational inequalities, just a reminder to find zeros and undefined points. So the thing you have to be careful of is if it's a 0 and it's less than or equal to 0 or greater than or equal to 0, you can count it. But if it's an undefined term, you can never count it. But it can be a boundary. So this next problem is our first rational inequality. This is number 4, 3x plus 4 over x plus 2 minus 3 is greater than or equal to 0. So a couple of notes for rational inequalities, and these are steps that you should take. So your first step is to get one side to be 0. Get one side to be 0. Your second step is to make the one side that has stuff into a single fraction. Make a single fraction. Single fraction. And then step 3 is to find zeros and undefined terms. Zeros and undefined. And step 4 is to make that interval table. Interval table. And see what works. So I wrote those steps because step 1 is already taken care of in this problem, but this could have easily been this fraction is greater than or equal to 3, right? You know, so then we'd have to subtract 3 from both sides. We'd get this. Once we have this, we have to get a common denominator. And okay, I will comment that in the previous section, we didn't get a common denominator. We got rid of the fraction, right? But that's not what we want to do here. We don't want to get rid of the fraction. We just want to get a common denominator. So x plus 2 is the common denominator. 3 is like 3 over 1. And so all I'm going to do is multiply 3 times x plus 2 over x plus 2. And so that's going to give me that common denominator. I'll just rewrite this one more time. 3x plus 4 over 2, or x plus 2, is subtract 3, x plus 2, x plus 2, just to kind of see that that's my common denominator. And then I'll write it as a single denominator, x plus 2. I want to be careful when I distribute that to distribute it as a negative 3. So I have 3x plus 4 minus 3x minus 6 is greater than or equal to 0. And this one turns out to be, you know, like unremarkable in my mind, but that's okay. So what's 3x minus 3x? They cancel out. What's 4 minus 6? So I get negative 2 over x plus 2 is greater than or equal to 0. So the reason I call this unremarkable or whatever is there's no factoring in either place, you know. There's not even an x in the top to give me any zeros. So all I have, there are no zeros. Oops, zeros. And my undefined is when that denominator is equal to 0. Oops, is when x is negative 2. So I just have to kind of keep that in mind, that that's where it's undefined. That's the only key value I have in this one. When I go from negative infinity to infinity, oh, I don't know why I made that so long, because I just have that point of negative 2. Now, when I do this one, I'm looking at this version, but generally it would be the factored version, right? Because, you know, there really wasn't any factoring to do there. What's my interval table going to look like? Justin, what are my intervals? I have 2 of them. Yep, negative infinity to negative 2 and negative 2 to infinity. And then I'm going to pick an x value and find the sign of y. Amy, tell me an x value between negative infinity and negative 2. Negative 3. And so on this one, the top is negative 2, so it's just negative. And the bottom, when I put in negative 3, Amy, will that be positive or negative on the bottom? Negative. And a negative divided by a negative is a positive. So we've got that. Madison T, pick anything from negative 2 to infinity. 0. And this is negative 2, so that's negative. And when I put in 0, is that positive or negative? Positive. And a negative divided by a positive is a negative, as we look at that. So then up here on my chart, that was a positive. This was a negative. I'll revisit this. This is when it's greater than or equal to 0. So I want these positive ones. However, when I do this, can I include the negative 2? No. Even though it says or equal to, I can't include the -2 because that's not a 0, it's an undefined term. So undefined can't use. I'll just say that. We can't use it. It just can be a boundary. So when it's greater than or equal to 0 from -infinity to -2, not including that. So our solution, maybe I'll just show that solution, is from -infinity to -2, and our graph is there. I'm always a little hesitant to show the graphs because sometimes the book authors don't have good graphs, but I didn't make a note on that. And I can use my graph to just validate that. Do you agree that all of these values are positive? It's always positive up there, it's always negative there, and it's undefined there. And truly, you don't have to graph it at all, but you should probably graph it as a check to yourself. Use graphing as a tool to check that. Say that again. Because it's this fraction, and if I put in -2, I get a 0 on the bottom, so anything divided by 0 is undefined. Now, I'm going to give you a problem. Are you ready for it? Ready? Okay. Do you want me to take away the multiple choices? Sure, I want. Of course you do. So, there they are. Now, what's the very first step? Get one side equal to 0, and then get a common denominator. So you got a little work to do, and then see what happens. I'm going to pause this, and then when we're ready to go over it, I'll then. Okay, so the job there, I had turned this off, is to subtract 1 from both sides, and then get a common denominator, which is 2x minus 6. And we multiply by that over itself. We don't want to get rid of the fractions. We just want to get that common denominator. And then I went up over here. Then we end up with this as our rule. We find that 11 is a 0, 3 is where it's undefined. And so then our interval table is going to go from -infinity to 3, and from 3 to 11, and from 11 to infinity. When we try some x and y values, and you guys tried that, so what is that first interval, positive or negative? Negative, the next one? Positive, and the last one? Negative. So I'll let you kind of fill that in if you weren't sure. Now, the deal here is this is greater than or equal to 0. So in our minds right away we think, oh, it includes the endpoints. But does it include 3? Well, oh, no, it does not. Does it include 11? Yes. So this one is okay. This one is not okay. And when is it greater than or equal to 0? Kind of in the middle there. And so it's a parenthesis there, and including that, and then a bracket. So our solution is from, let me write solution, from 3 to 11, not including the 3, but including the 11. Does that make sense? Because the 3 was from the denominator undefined. Yep. So if it's just a polynomial, like, you know, the yesterday problem, they're all zeros, so if it's greater than or equal to, less than or equal to, it's included. Here, if it's from the bottom of the fraction, it can't be included. Now, the next problem I'm actually going to save and go out over on Monday. For those of you, oh, let me turn this off then. I'm kind of done with